the most interesting conversations in my life. An organization in the healthcare sector gave me a call and they said to me that they'd been developing a model that was pretty exciting and groundbreaking. This model, a model that they'd invested a little over $5 million in, was meant to help them with medical diagnosis. This is one of the biggest issues that you find in healthcare today. What this model was meant to do was, it took hundreds of thousands of medical images of a particular disease, went through what we call a convolutional neural network to be able to find out what the different components that made and constituted that disease looked like, and then gave an output that allowed them to be able to introduce an X-ray of a new patient and then be able to tell, or with a level of probability, whether or not this patient had this disease. Now, when we were having the conversation, it was very interesting because the numbers they were talking about were outstanding. The first thing that they had was they had a precision of 92%. Do you know how difficult it is to get there? And the data scientists that had been working on the project had fine-tuned and changed the parameters over and over again and worked through this model for a painstaking 5 years. But at time of launch, a crisis ensued. What happened was, when they introduced new data to this model for it to be able to diagnose, it was starting to get a lot of false positives. This meant that what would happen is they'll bring data of particular patients, and once this data comes in, it would then lie, if I can say, that this person had the disease, when clearly from the labeled data that they had on the table, it said that this patient does not have the disease. And they then ran the experiment over and over and over again to try and figure out whether or not this was maybe a one-time thing or not. But they found that the more diverse patients they tried this with, the more it was getting it wrong. So what they did is, 2 weeks before launch, and they announced to the press that, we are launching this groundbreaking thing. The executive was ready, the board was ready, because all the test results had been successful initially. So they gave us a call and they said, guys, you need to come in here, you need to come in here now. You've got to see what's going on with our data, what's going on with our model. What we found there was scary. Number one, we found that these guys in their training set had trained the algorithm with a specific type of patient, right? So this means this specific type of patient or type of patient profile only constituted about 30 or 40% of their total patients. So because of that, the constitution and the development of this particular disease in those on that customer profile or patient profile did not match the way it was for other groups of patients. So what this meant was that when you introduced a patient from outside of this box, you would get results that were wrong because the attributes that the model had been trained on had been on the other side. So we looked into that, we sat down with the team and we said, listen, you've got to first understand that before you build this model, you've got to make a plan for the data. Because the importance of data in these particular projects is your data has got to be a good representation of all the different patients that you have. Because if you do not have a good representation of all the different patients or the phenomena that you have, what will happen is that your model will be biased towards specific outcomes or different types of customer profiles. And so ultimately, what you'll find is that your model that was working pretty well, in the testing environment won't be doing as well in production because a lot of things change. And this really was a very interesting lesson around ensuring that when you're building these AI projects or these data science projects, it's very critical for you to ensure that you've got a diverse set of data around all the different types of combinations that you have. And the labeling that is done from a point of understanding all the different types of combinations that could come through, and that it involves all the different parties around it. This way, you can be able to solve the situation. So we had to unfortunately tell the board of this organization that you've spent all this money on this project, you've spent all this time on this project, but unfortunately, this can only help about 40% of your clients. So we had to start again. We had to rebuild the data sets. We had to look for data from external sources around different institutions to be able to find out how exactly we could be able to help them out. And then from there, we had to take that data and then start working on labeling, the different profiles, involving the different types of patients that we're looking at, as well as different specialists across the spectrum. This allowed us to be able to have an even more balanced data set. Once we made sure that our data set was very well balanced, the easy part really was training the model. Because the idea was, once we could be able to profile our clients and patients in different ways, the model was then able to now find all the different distinct versions for us. And whilst our model did not necessarily get to 100%, which is something that's almost impossible, we were able to predict the presence of this disease by between 85% to 90%. And this really helped this organization to be able to help them prioritize treatment for patients. Because the idea was, if we can be able to tell that this patient has this disease at a very high degree or high probability, then preference must be given to them in order for us to be able to speed track that and help doctors prioritize their workload. This was a very important discovery and helped to ensure that this is something that they can continually use, something that they're actually still using to this day with no problems. Catch us next time.